All right, this is going to be T12.3 through 12.5. A random sample of traffic tickets given to motorists in a large city is examined. The tickets are classified according to the race or ethnicity of the driver. The results are summarized in the following table. All right, so the categories we have are white, black, Hispanic, and other. The proportion of this city's population in each of the racial/ethnic categories listed is as follows. So 55% of the population is white, 30% black, 8% Hispanic, 7% other. We wish to test the null hypothesis. The racial/ethnic distribution of traffic tickets in the city is the same as the racial/ethnic distribution of the city's actual population. So 12.3. Assume the null hypothesis is true. What is the expected number of Hispanic drivers who would receive a ticket? All right, so we know 8% of the population is Hispanic, so if the null hypothesis were true, 8% of our sample of traffic tickets should come from the Hispanic category. All right, let's first figure out what the total sample size is. All right, so what is the sample size here? So we got 69 plus 52 plus 18 plus 9. Okay, 148. All right, so let's figure out what is 8% of 148. Okay, it's about 11.84. Okay, so 0.08 times 148 is 1184. All right, choice D. Right, 12.4. We compute the value of the chi-square test statistic to be 6.57, assuming that the conditions for inference are met. Which of the following is correct? Okay, so we need to figure out what the p-value is. Okay. Also, if we take a sneak peek at 12.5, it's asking for the largest component to the chi-square test statistic. So we could answer both of these questions simultaneously if we just run the chi-square goodness of fit test on our calculator, because that test, that function, is going to give us the p-value, and it's going to give us all the components. Okay. All right, so let's go ahead and do the following. I'm going to go to the list here. And let's go ahead and clear that out. Okay, we're going to put the observed counts in list 1. So 69, 52, 18, and 9. Okay, and then in list 2, we're going to put the expected counts. Okay, so for white, it's going to be 55% of 148. So notice here that I'm just basically writing an expression, right? And then the calculator, once I hit enter, will figure out what that expression evaluates to. All right. For black, it's 0.3 times 148. Okay. For Hispanic, it's 0.08 times 148. And for other, it's 0.07 times 148. Okay. All right. So we've got observed counts, expected counts in our lists. Now we can go run our chi-square goodness of fit test. Okay, list 1, list 2. Okay, degrees of freedom. It's going to be the number of categories minus 1. So we have 4 race, ethnicity categories. 4 minus 1 is 3. All right, let's calculate. All right, so there's our test statistic, 6.57. Okay, matches with what the question stem said, right? 6.57. The p-value is 0.08. 68. All right, so that's greater than 5%, but less than 10%. All right, so there's our answer to question 4. And then question 5, we're looking for the largest component. Okay, so the calculator calls them contributions, right? You might see it, like you can see this test uses the word components, but it's talking about the same thing. All right, so we've got 1.88, that's for white. 1.3, which is for black. 3.2, that's for Hispanic, it's the largest one so far, and 0.17. Okay, so the largest contribution comes from the Hispanic category. Okay. So we could eliminate A, B, and D. All right, now the question was, were there 6.16 fewer tickets than expected or 6.16 more tickets than expected? Right? Let's go back to the list and see. All right, Hispanic was third category, right? So we had observed 18, expected less than 12. Okay, so we observed more than expected, right? More tickets than expected. Choice D.